All right, hi my Math 7Ds, I'm back. This is another Centroid problem for you guys. It is covered in the 8.3, 9.1, 9.3 extra problem section under files and Canvas. I am going to cover number 20 now, which is this problem. Find the centroid of the region bounded by the given curves. We have 4 different curves here. We're going to find that we only need 2 of them to define what the top and the bottom function would be. Again, if you guys do want to see this done in the other variable, once I'm all done with this, just let me know so I can go over that with you. All right, so the first thing I want to do is find us our whiteboard here. Okay. And then just going to rewrite our equations for the centroid. Let me go back to my regular color here. Okay, so what we had discussed already is that for your area, you're going to be using A to B for your limits of integration. And then you're going to have your top function minus your bottom function that you integrate. So this is top function minus bottom function. Just note if you are using y, we typically use C to D for the bounds. And then we would have something like, let's see, we'll just still use the same functions. F is a function of y now. And G is a function of y. And you would be taking the rightmost function minus the leftmost function. Okay. I'm going to be working in X today. So I'm going to go over your X bar, which is 1 over your area of the region times the integral from A to B. You have X times F of X minus G of X dx. And Y bar, 1 over 2A, A to B. You have F of X, the quantity squared, minus G of X, the quantity squared. Dx. Okay, so I'm not going to go over the X bar, Y bar equations for this part right now. All right, so these will be the equations we use. Let me go ahead and erase the stuff we don't want right now. And we're going to write in our equations. So we have our equation 1. That is y equals 6 sine of the quantity 4x. We have equation 2. That's y equals 6 cosine of 4x. We have equation 3, which is x equals 0. And we have equation 4, which is x equals pi over 16. So we actually want to graph all of these. Graph the region, find intersection points. Okay, so let's just start by finding the intersections. We can kind of tell from these bounds right here that it'll probably happen when x is equal to 0 and x is equal to pi over 16. So for intersect, when x is equal to 0, we're going to look at equation 1 and equation 2. We have y equals 6 times sine of 4 times 0. That's 6 times sine of 0. Sine of 0 is 0. So we get 0. And then we also want to look at equation 2. Y equals 6 cosine of 4 times 0. That's 6 times cosine of 0. Cosine of 0 is 1. So we get 6 out here. So the intersections that we get on the leftmost side of our graph will be 0, 0 and 0, 6. We can go ahead and kind of take a look at that over here. Okay. So we're going to have pi over 16 and then 0. All right, so we know that 0, 0 and 0, 6 will be points. Okay. Let's go ahead and draw in the lines that we know, so maybe you'll have a better idea of why I'm thinking about it this way. So from equation 3, that's when x is equal to 0. Okay, and then from equation 4, that's when x is equal to pi over 16. So I can tell that my left side is going to be a cutoff and my right side is going to be a cutoff. Okay, so I'm just trying to see, where does equation 1 meet equation 3? Where does equation 2 meet equation 3? We just answered both of those. Now we're going to figure out, where does equation 4 meet equation 1 and equation 2? So back in black, we have x equals pi over 16. Plug in to equation 1 and 2. So that's 6 times sine of 4 cancels with 16. You get a 4 on the bottom. That's pi over 4. And then that's 6 root 2 over 2, which is 3 root 2. Which comes out to be about 4.24. Okay. And then equation 2, where does it meet equation 4? Six cosine of pi over 4. Cosine of pi over 4 is also root 2 over 2. So we actually get the same thing. So the intersect points here, pi over 16, 3 root 2. Pi over 16, 3 root 2. Let's go ahead and mark 1, 2, 3, 4, and 5. And then again, you can take averages to find middle values here. This pi over 16 is equivalent to 2 pi over 32. So in the middle, 3 pi over 32. You could just take averages traditionally though, if it's easier. We're also gonna have pi over 64 and 3 pi over 64. Okay, just to continue the color codedness so you can see what I was comparing before. This was your equation 4. And then this was equation 3. So we're just trying to see where do these curves intersect. So now we're going to do a table of values. I'm going to go ahead and erase. Actually, before I erase, let's draw out the intersects that we have so far. We already saw 0, 0, and we saw 0, 6. Now we have pi over 16 and about 4.24. So right about here, let me make that. Okay. All right, now let me erase all this stuff. One day I'll be well versed enough to like talk and things while doing this. Not yet though. Okay, so graph equation 1 and equation 2 now. And you can tell that they're both functions in terms of x. So we are going to use an x table. So x over here. And then we'll have equation 1. And then we'll have equation 2. Should write it in there. Okay, so for x, we found out that 0 and pi over 16 would be our bounds. Then we take averages to find some other values to check. We're actually going to plug these in and approximate. So we get 0, approximately 1.17, approximately 2.30, approximately 3.33, and approximately 4.24. Okay. And then we get for the cosine function 6, approximation 5.88, approximation 5.54, approximation 4.99, and final approximation about 4.24. Let's graph equation 1 in red. We have 0, 0, pi over 64 and 1.17. Pi over 32, 2.30. 3 pi over 64, 3.33. And finally, pi over 16, 4.24. Let's hope I can curve this out smoothly. Yay. So equation 1. And then let's go over equation 2. We start at 0, 6. And then we have pi over 64, 5.88. Pi over 32, 5.54. 3 pi over 64, about 5. And then this last value here. This is equation 2. And then the area that we're considering for the centroid is right here. Okay, so we have our situation graphed, and the whole purpose of graphing that is so that we can figure out that equation 2 is actually on top of equation 1. Okay, all right. So let's clear out our table now. Okay, awesome, almost. Great. Okay, so now we are ready to establish which function will be f of x and which function will be g of x. So what we found is that our function f of x on the top is going to be equation 2. And the bottom function is going to be equation 1. Sorry, my cat is waking me. Okay, so, okay, apparently my internet connection is unstable. No, we'll see how this goes. Hopefully I can get through this. All right, so first thing we're gonna do, we're gonna find our area of the region. Now remember, for A to B, what you're looking at is from left to right. So we're gonna have 0 to pi over 16. Those are in terms of x, which is perfect because you're gonna have in terms of x for your integration as well. So we have our top function minus bottom function. And then dx. So I'm going to factor out a 6. 0 to pi over 16 still. Now we have a cosine 4x minus sine 4x dx. So next step, 6, we can actually go ahead and integrate. You can use a u sub. Essentially, you're going to get 1/4 sine 4x plus 1/4. Let me actually show this part. So we have a subtraction here already, right? But then for the sine 4x part, put it in deeply. You're going to get negative 1/4 cosine 4x. And that's from 0 to pi over 16. So that is 6/1/4 sine 4x plus 1/4 cosine 4x from 0 to pi over 16. I'm going to factor out a 1/4. I have sine 4x plus cosine 4x from 0 to pi over 16. Let me dot this because it will be good to show. It's a good algebraic exercise. You would typically give something like this in an exact answer form, not a decimal form, unless you were asked for that or is an application problem. All right, so basically we have our area. You see that 6/4 is going to become 3/2. Go ahead and plug in your bounds, upper first. Okay, and then you're subtracting sine of, remember when we plug in 0, we don't really care about the 4, but I'll write it in anyway. And then this is also going to turn into a minus. So that's 3/2 sine of pi over 4 plus cosine pi over 4 minus sine of 0 is just 0. And minus cosine of 0 is going to be 1. Okay, let me erase this bottom line so it's not confusing that we just left it. All right, so then we get 3/2 of √2/2 plus √2/2 minus 1. That's 3/2 times 2 of these √2/2s minus 1. 2 cancels out. You have 3/2 √2 minus 1. Or 3√2/2 minus 1/2. Or our preferred version is just going to be to put the numerator stuff together and then divide it by the denominator stuff. And you'll see why this is preferred in a moment. It's pretty much because when you have this part for your x bar or your y bar, you can essentially just flip the numerator and denominator instead of having to do algebraic putting back together and flipping. So we have our area, and we are ready to move on to x bar. So let me clear out this nonsense here. And all this. Let me move my area term over here. Okay, that's not gonna work out. I'll just rewrite it over here in purple. Almost there. Lots of 2's left. All right. So let's go back to black and draw. We're going to find X bar. So X bar is equal to, so 1 over A, right? So if I'm taking 1 divided by this, it just flips numerator and denominator. Okay, you're not sure, actually try it. Plug in the 1 divided by all of this and then do old school division. All right, now we have integral from 0 to pi over 16. X times, remember you have your top function, that's going to be equation 2. In terms of X though, you just want to use the expression that Y is equivalent to. This one. Let me clear, because I saw I made a mistake there. That needs to be a cosine. Okay. So top function, and then we're subtracting your bottom function in terms of X. And then popping a dx on there. So some of these steps will be pretty similar. Like I'm going to factor out a 6. It's going to come into this fraction here. So 6 times 2 divided by 3 times root 2 minus 1, the quantity. We have 0 to pi over 16. And then from here, you're going to have x cosine 4x minus x sine 4x dx. So 12 on top, divide 3. I'll go ahead and write that out. You see that that fraction is simplifiable, but we'll come back to it. Okay, so we get 4 divided by root 2 minus 1. And then over here, what we're going to find is that this is going to be an integration by parts for both of these. I'm going to skip the nonsense from the integration by parts for this particular video, but I will put in what you should have for your integrals in 1 second. So for this part, I'll just put a dot, dot, dot for now, and I'll go ahead and rewrite it in next step. I'm going to go ahead and erase the stuff on the top so I'll have a little bit more room. Yeah. Okay, so let me go ahead and write what we have here before I forget. Let's put, okay, so we have x bar equals 4 over root 2 minus 1, integration 0 pi over 16. I'm going to put x, a little too close in color. Let's choose, I'll just keep it yellow for now. So x cosine 4x minus x sine 4x dx. Okay. Hopefully you guys can't hear all that scraping from this board. This tablet's quite noisy and erasing. All right, so let me put what hasn't changed in black. Okay, and then I'm going to put my integration by parts in the appropriate color. So first bit, x sine 4x divided by 4 plus cosine 4x divided by 16. Still have a minus out here. Let me go ahead and erase this over here so I have more room. And then for this next part, integration by parts for the red is going to be sine 4x over 16 minus x cosine 4x over 4. And that's evaluated from 0 to pi over 16. All right, so I'm going to rearrange some things. 4 over root 2 minus 1. Okay, I'm going to put my stuff that's over 4 together. X sine 4x plus x cosine 4x all over 4 plus cosine 4x minus sine 4x divided by 16. That's optional. It's just because it looks a little bit nicer when you're putting all your stuff in, like plugging in and simplifying. Next step, 4 over root 2 minus 1. And then we have a lot of plugging in to do. So pi over 16 sine 4 times pi over 16 plus pi over 16 cosine pi over 16 all over 4. Erase this too. It's clearly getting a little bit longer. Plus four times 5 over 16 and minus okay, so that's just your first bit from the pi over 16 part. So you're still going to need to subtract when you plug 0 in. So hopefully you can see from this first bit, plugging 0 in here will give you a 0. And then we have minus cosine of 4 times 0 minus sine of 4 times 0 divided by 16. All right, so we get a lot of stuff here, right? Pi over 16 you can factor out and then divide by 4. That becomes pi over 64. And then you're multiplying by sine of pi over 4 plus cosine of pi over 4. And then over here, we have cosine of pi over 4 minus sine pi over 4, all divided by 16. And then from the part you're subtracting, you have cosine of 0 minus sine of 0 over 16. So this part's going to cancel because cosine of pi over 4 is equal to sine pi over 4. And then sine of 0 is 0. So let's see what we have left over. We have pi over 64. This is root 2 over 2 plus root 2 over 2 minus 1 over 16. Okay, sorry, that got a little merged there. Okay, I couldn't select that apparently. It just ran off on me. Okay, so then hopefully you'll get the point and can do the rest of the algebraic steps. But essentially what we get out of this is pi root 2 minus 4 divided by 16 times the quantity root 2 minus 1. So that's x bar. We have to find y bar now, and then we're done. So a 3 times root 2 minus 1 over 2 x bar pi root 2 minus 4 over 16 times root 2 minus 1. We find y bar, and then we have our x bar, y bar for the centroid. Let me erase. Hopefully you can see how some of the old methods that we've used have come into play here, like using integration by parts twice in the middle of this long problem, right? So, of course, when you're working on items that are not quizzes and tests and things, you'll be able to use technology to help you a little bit faster with that part. But do be familiar with the processes unless you do need to find them the long way. Almost there. All right. Last bit, y bar. Essentially, remember that was 1 over 2a times integral a to b. We had f of x, the quantity squared, minus g of x, the quantity squared, dx. So y bar is 1 over 2 times 3 times this quantity divided by 2. And then we have 0 to pi over 16. Remember, your top function was equation 2, which was 6 cosine of 4x. You're going to square that. Subtract. You have 6 sine of 4x. You're going to square that. So your dx. So 2's cancel here. You have 1 over 3 times root 2 minus 1. Hopefully you're seeing you can factor out a 6 squared here. I'll take this one a little bit slower. And then you have cosine squared of 4x minus sine squared of 4x dx. Right here, it's actually an identity. Cosine of 2a would be cosine squared a minus sine squared a. So cosine squared of 4x minus sine squared of 4x would be cosine of 8x. Don't confuse yourself. Remember, that's not a plus, so don't make that a 1. It would make things a lot nicer, but we can't do that. All right, so we have 36 that comes out divided by 3 root 2 minus 1. And then we have 0 to pi over 16 of cosine of 8x dx. We can use a u sub here. And we can simplify 36 over 3. So this integral turns into 1 over 8 sine 8x from 0 to pi over 16. Eight can come out. It's going to cancel down with the 12 to 3/2. You still have root 2 minus 1 as a factor multiplied in the denominator. We have sine of 8 times pi over 16 minus sine of 8 times 0. Which is 3 over 2 times root 2 minus 1 times, this is sine of pi over 2 minus sine of 0. Sine of 0 is 0. And sine of pi over 2 is 1. Okay, save this. So then what we get for y bar equals 3 over 2 times root 2 minus 1, or 3 over 2 root 2 minus 2. Okay. It's fine, I just use the first one. So what we found from this then is our centroid location after all that work. I would say that's the worst part, one of the worst parts about calculus, that some of the problems are just horribly long. And it does, I'm not gonna lie, get a little bit worse in your later math classes, but you know, this is very entertaining. I love math and hope that you do too, have the appreciation for it to bear through some of this nonsense. All right, so our centroid is located at pi root 2 minus 4 divided by 16 times root 2 minus 1 and 3 over 2 times root 2 minus 1. Let's actually come up with an approximation for that just so that we can put this together here. I don't know why I didn't think to do this part before, so I'll just go ahead and calculate it now. I have a calculator nearby. Definitely not doing that by hand. So, it's 4 divided by 16. 3, 2 minus 1. So for x bar, we get about 0.07. 3 divide 2 times root 2 minus 1. Okay, so that comes out to about 3.62. So let's check this. Centroid, pi over 64 is about 0.05. Pi over 32, about 0.10. So your x value for the centroid should be between pi over 64 and pi over 32. And then we're going to move up to 3.62, somewhere about there. Okay, so our centroid is about there. Okay, thanks for bearing with me through all this. I'm going to review this, make sure everything is smooth with it, and then I will post this on my YouTube channel later tonight with more information for you guys about how to do these problems. Please let me know if you need any assistance in the meantime. You need to set up a Zoom or you have any questions, you're more than welcome to ask me. Remember, you're not alone in this. I know how stressful it can be, especially having to change your entire schedule and work from home, but we will make it through this. Till next time.